All right, so we are on our last section of material for exam 3, and we are going to talk about the search for causality, and I want to make sure real quick because I made that statement to you. Yes, it is. All right, because there are 3 more sections we will cover. They'll show up on the final, and so you'll need to be aware of that. You'll have to know those things for the other 3 sections, but they won't be on this exam, okay? If it changes, I'll let you know. All right, so the search for causality. Suppose you have discovered a correlation and suspect causality. How can you test your suspicion? Well, the strong correlation between smoking and lung cancer did not by itself prove that smoking causes lung cancer. In principle, we could have looked for proof with a controlled experiment, but such an experiment would be unethical because it would require forcing a group of randomly selected people to smoke cigarettes. So how was smoking established to be a cause of lung cancer? Well, first of all, the researchers found correlations between smoking and lung cancer among many groups of people: women, men, people of different races, different cultures. Among groups of people that seemed otherwise identical, lung cancer was found to be more common in smokers. People who smoked more and for longer periods of time were found to have higher rates of lung cancer. When the researchers accounted for other potential causes of lung cancer, such as exposure to radon gas or asbestos, they found that almost all the remaining lung cancer cases occurred among smokers or people exposed to secondhand smoke. So those 4 lines of evidence made a strong case, but still did not rule out the possibility that some other factors, such as genetics, predisposes people both to smoking and to lung cancer. So one line of evidence came from animal experiments. In controlled experiments, animals were divided into randomly chosen treatment and control groups. The experiment still found a correlation between inhalation of cigarette smoke and lung cancer, which seems to rule out a genetic factor, at least in the animals. Biologists studying small samples of human lung tissue, they discovered the basic process by which ingredients in cigarette smoke creating cancer-causing mutations. This process does not appear to depend in any way on specific genetic factors, making it all but certain that lung cancer is caused by smoking and not by any pre-existing genetic factor. The fact that secondhand smoke exposure is also associated with some cases of lung cancer further argues against a genetic factor, since secondhand smoke affects non-smokers, but is consistent with the idea that ingredients in cigarette smoke create cancer-causing mutations. So they used a lot of guidelines here to do this. So we're going to follow some guidelines here for establishing causality. So we're looking at the causality. Does this cause that? And that's what they looked at, the 6 guidelines. So if you suspect that a particular variable, the suspected cause, is causing some effect, you have to look for the situations in which the effect is correlated with the suspected cause, even while other factors vary. Among groups that differ only in the presence or absence of the suspected cause, you need to check that the effect is similarly present or absent. Rule number 3, or guideline number 3, is look for evidence that larger amounts of the suspected cause produce larger or smaller amounts of the effect, and if the effect might be produced by other potential causes besides your suspected cause, make sure that the effect still remains after accounting for those other potential causes. If possible, test the suspected cause with an experiment. If the experiment cannot be performed with humans for ethical reasons, consider doing the experiment with cell cultures or computer models, and try to determine the physical mechanism by which the suspected cause produces the effect. Now, there's a thing called hidden causality. So far, we have discussed how to establish causality after first discovering a correlation. However, sometimes a correlation or the lack of a correlation can hide an underlying causality. So there's broad levels of confidence in causality. There's possible cause and a probable cause. And then cause beyond a reasonable doubt. So it's kind of like court cases. So the possible cause, we have discovered a correlation but cannot yet determine whether the correlation implies causality. Probable cause, we have good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality are satisfied. And then cause beyond a reasonable doubt, we have found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. So 3 levels there. We think there's a possible cause. It looks probable, and you know what? We're seeing cause beyond a reasonable doubt. All right, so does it make sense? If a collection of paired sample data values yields a correlation coefficient of r equal to 1, then we can be very confident that causality is involved. All right, so r equals 1 is supposed to give us a perfect correlation, right? However, with this one, so this is 7.4 example 1, even though we have a perfect correlation of r equals 1, it can occur, it may occur, due to coincidence. Or a common underlying cause. So we're going to say does not make sense. Because there could be, oops, I'm totally off the screen, so sorry. With r equals 1, it may occur due to coincidence or a common underlying cause, so it does not make sense. Alrighty? So sorry about that. Next question. Does it make sense? If causality has been established beyond reasonable doubt, then we can be 100% confident that the causality is real. Okay, beyond reasonable doubt. Well, reasonable doubt is not the same as all doubt. So there's always going to be a chance that a conclusion is incorrect, even though it's been established beyond reasonable doubt. So, example 2 does not make sense. Reasonable doubt is not the same as all doubt. So beyond reasonable doubt is not the same as beyond all doubt. So there's a chance that it could, a conclusion is incorrect. Okay, so be aware of that. Doesn't mean absolute. All right, so end of our handout. That's the end of this section of material. You have, I don't believe we have homework in this, but you now have an activity that you might have been working on already. There's an activity that goes with this set of information. So you're going to determine on the graphs that I have here if there's a positive, negative, or no correlation on the graph. And if it's positive or negative, I want you to also decide if it's perfect, strong, or weak. If it doesn't have a correlation, you won't click on perfect, strong, or weak. It won't have an answer there. Okay? If there's no correlation, you leave the bottom row blank. And then on the back, I have given you a table in two parts, two tables. You need to find the R factor, or the R correlation coefficient, sorry. So find the exact value of that and find the equation of the best fit line. So that'll give you some practice in both of the correlation and best fit line. You can use Desmos to do this in order to get this done. And then also the thing that you should be working on next is you have another project. This is a project in StatCrunch for the project for regression. So you've got instructions here on how to get in there, going into the data sets, using weekly influenza tests in that year range, load the data, and then, so this is what you're looking for, and load it into the deal. So it's going to go put it in, and then you're going to follow all the steps here, and then write a small interpretation and upload the results, including those. So again, you're going to do some screenshots. So that's kind of what you're seeing here are my screenshots, okay? And then submit it as one PDF document so that I can grade that. So I believe this is project 4. And then the other thing you need to be working on is your exam review, which is also in D2L. So remember, these are up to 5 bonus points on the exam. You need to work them on separate paper, neatly and in order. Submit it as a single PDF. It's due before you take the exam. It's up to 5 bonus points, and it's still a daily quiz grade. You need to work it out, and on the back, there is a bit of a key. Don't copy my key exactly. You need to be working it out. This is to check yourself, right? So don't give me word for word the type of things there. And show me all the math involved, because I don't always have all the math. I just have, like, kind of where it's getting to, the final answer. All right? So make sure you're starting to study for exam 3 so that you're prepared to do well on that. And like I said, there's still 3 sections of material that we'll go into after exam 3.